this video, we will look further at derivatives of log functions. Suppose we have y equals log f. Then we know from the chain rule that the derivative of y will be 1 over f times derivative of f. That is, the derivative of log f is f derivative over f. A rather useful result is that a positive function f will have a stationary point at the same location as log f. This claim is not too difficult to prove. If log f derivative is 0, then that means f derivative over f is 0. In other words, f derivative is 0. Therefore, extremizing log f will extremize f. Let's look at an example. Find the value of x that minimizes the function y equals 1 over root 2 pi e power minus x minus 1 squared times 1 over root 2 pi e power minus x minus 2 squared times 1 over root 2 pi e power minus x minus 3 squared. Using the result that extremizing log f will extremize f, that is, the stationary point for log y is at the same position as y, we should take the log of both sides here to help simplify the problem. Log y is equal to log the right hand side. Since this is a product of 6 terms, we can use the fact that log xy equals log x plus log y to simplify this further. This will equal log 1 over root 2 pi plus log e power minus x minus 1 squared plus log 1 over root 2 pi plus log e power minus x minus 2 squared plus log 1 over root 2 pi plus log e minus x minus 3 squared. Grouping the log 1 over root 2 pi together and cancelling the log and e, we have the result shown. Now we will differentiate each term. The derivative of 3 log 1 over root 2 pi is 0 because this is a constant. For the next 3 terms we will need the chain rule. The derivative of x minus 1 squared is 2 x minus 1 times 1. Bring down the power, reduce the power by 1 and multiply by the inside derivative. This is done again for the last 2 terms. It will be almost identical. Dividing everything by minus 2 and we have 0 equals 0 plus x minus 1 plus x minus 2 plus x minus 3. Grouping similar terms together, we have 3x equals 1 plus 2 plus 3. That is, x equals 2. Find the tangent to the curve below at the point x equals 0. And the curve is y equals log 1 plus x squared. First note that when x is 0, we have y equals log 1 equals 0, and so the point is 0, 0. Y equals log 1 plus x squared. The derivative here will be 1 plus 2x over 1 plus x squared. We put in the point 0, 0 and we find that m is 1 plus 2 times 0 over 1 plus 0 squared. That is, m is 1. So the equation of our tangent line will be of the form y equals 1x plus c. Substituting in the point 0, 0 to find c, and we conclude that c must be 0, and hence the equation of the tangent is y equals 1x plus 0. Here's one I'd like you to try. Find the equation of the tangent to the curve below at the point x equals pi over 4, and the curve is y equals minus log cos x. Pause the video, try this example, and resume when you're ready to see the answer. When x is pi over 4, y equals minus log cos pi over 4, which equals minus log 1 over root 2, which equals minus log 2 power minus a half, which equals a half log 2. So our point is pi over 4 and a half log 2. Y equals minus log cos x. That means the derivative will be minus sine x over cos x, which is tan x. Evaluating this at our point, x is pi over 4, and we find that m is equal to 1. So the equation of the tangent line will be of the form y equals 1x plus c. Substituting in our point pi over 4 and a half log 2, we get a half log 2 equals pi over 4 plus c. Therefore, a half log 2 minus pi over 4 equals c. And we have y equals x plus a half log 2 minus pi over 4. Find the stationary point of log x squared plus 2x plus 2. What is the nature of it? Pause the video, try this one for yourself, and resume when you're ready to see the answer. Y equals log x squared plus 2x plus 2. The derivative here will be 2x plus 2 over x squared plus 2x plus 2. And we require this to be equal to 0. Therefore, we require 2x plus 2 to equal 0, and that will result in x equal minus 1. Now we need to determine if this point is a maximum or minimum, so we require the second derivative. Recall that the first derivative was 2x plus 2 over x squared plus 2x plus 2. To find the derivative of this, we will need the quotient rule, which is the bottom times derivative of the top, in this case 2, minus the top times derivative of the bottom, all over the bottom squared. We have 2x squared plus 4x plus 4 minus 4x squared minus 8x minus 4 all over the bottom squared. I just multiplied out in the numerator. Grouping together similar terms, I'll find that I'll be left with minus 2x squared plus 4x over x squared plus 2x plus 2 squared. Now I need to evaluate this at the point x equals minus 1, and I'll find that this will be a positive number. Therefore, x equals minus 1 is representing a minimum point, since a second derivative that is positive represents minimum points. And recall that a second derivative which is negative represents maximum points. That's all for this video.